intermediate will be formed only through this pathway, and not through trans and gamma pathway. We are doing the reaction in a low temperature condition. Okay, sir. Experimental characterization protocol, sir. So we have done NM. NMR characterizations can be done, sir. Experimental techniques, sir. Using NMR characterization, we can differentiate them, sir. Yeah, we are also we have taken NMR and courses taken, sir, in order to understand the technique, right? Sir, when I took this adenosine derivative, there is an amidine group. This NH2 group is there. We have it protected before doing aspiration, and we got a 75% in a paper, and that is from the work of Kushuma sir himself, and he suggested this paper, and he said they have protected this amidine group before doing this novo asphyxiation, and after that the production is done. Still the overall yield, even that is in the 3-step process, and the overall yield turns out to be again 75%. And also this particular reagent, DBFT, dibutyl formamide dimethylacetate, actually they have prepared that with a reagent called dimethyl sulfate, and that is turned out to be a carcinogenic compound, and so it is a hazardous thing to work with. So we suggest no need to do that, do the protection, because we are getting the same thing and the same yield without even protecting that particular group. So we suggested that it has a greener and a simpler alternative for that asphyxiation strategy. Docking studies validation. Actually, I have done the self-docking, the repeater docking, and also the while downloading the proteins, there will be some ligands inside it. So we just remove that ligands and again use that same ligand for the docking. So you got the similar pose, and from that we could validate the docking process so that we are getting the same poses. Then that's how we have done the docking validation. And about the fusion of a compound, actually we have done only in silico method. We have to do some in vivo method in order to find what actually will be the impact of that molecule on the biological system. So, thesis I have done botany studies with the mycobacterium only. Now we are doing it with different target topics or different diseases like cancer or something. So we need to consolidate everything and do we need to do the publication. Yeah, yes, sir. These are the transcripts of the application, sir. We are good.
Mitsunobu reaction that provide you an emotion, right? So how sure you are with the configuration, how you confirmed the stereochemistry of the assignment?
So using NMR spectrum, sir,
Yeah.
this was
Yeah. Yes.
this was a good query we got from the US Commerce paper, and there was a paper published in Yamamoto et al. That there
Yeah,
has
not from any reference, but I'm telling that if you take NMR, you can find out. I believe that in ocean, because the hydrogen with respect to the proton. So have you observed anything in the NMR spectrum? You got my question, right?
Yes, sir.
Yeah, you are claiming, not claiming is of course sure, that an emotion has happened.
Yes, sir.
But how? That's a belief, right?
Yeah.
But from NMR it's very clear. That's what, yeah, scientifically, how do you know that an inversion has happened? I mean from the NMR spectrum.
Here, the assigned molecule is creating a different environment here than H alpha and H beta, and it is creating the splitting patterns of hydrogen over here C1 dash, and since they are found to be in different environment, they will split in different manner. Like it will split into a doublet, and again it will be split.
Yeah, how can maybe looking into the structures, maybe if you look into the structures, maybe from there you can easily derive, you can find out that from the NMR, right? Because you have the hydrogens that are attached to the carbon, right? The carbon that you have done these processes, like the inversion, that means you attack.
Yeah.
So with regard to the carbon, so you have two hydrogens, right? So is it clear or it has merged somewhere? That's why you are finding difficulties. Are those protons clear in NMR? Because you see, you have in one case you have two trans protons, and in the other case you have only one trans proton. So that's clear. It should be clear in the NMR. From that you can derive easily the structure. So did you really observe that, or it was merged with something else?
We just play from this that can be possible.
Yeah, if you closely observe the NMR spectrum of this compound, you can at least find out the protons. Yeah, and from there you can confirm that the inclusion has happened. Thank you.
Thank you.
I appreciate you have included biochemistry into your work, little bit of microbiology, and you have done bioinformatics also. So working in an area like this, working in interface is really important. So congratulations. See, having completed your PhD work, it is very clear. Whenever you do this kind of work, you will be having so many challenges. Can you, for the sake of students who are there to submit their thesis, can you just highlight at least one of those challenges and explain how you could overcome that challenge?
In my experimental studies, the challenge I faced was the nucleoside-based drugs are very sensitive, and also it is a complete synthesis. So from one synthesis, we need to collect the product, and with that product we need to do the next one. So if we lose some product in midway, we cannot complete the entire scheme. So we need to do it again and again in order to get a quantity so that we can complete the entire scheme. So and also the purification was really very tough job, and the same reaction I have done many times not to get that particular product when I go to India. And also as a part-time research scholar, it was again a pulling task for me to complete a single scheme. And actually I had started my work under Dr. M. George sir, and I couldn't complete it initially there, and I was joined under him in computational chemistry, and later I joined under Shrima sir, and by around 6 years I took for completing this organic part, and probably I have taken around 12 years. So I took a decade of my life on it. Yeah, for sure. And I'm extremely happy that I could work in such a wonderful area. But nucleoside work was really very wonderful. And I'm so grateful that I could work on it.